this is Duncan and Sam. We're going to talk about our Chapel Hill topology. What's that bit there?
This bit is a server farm. It's got basically got your two main servers, Windows, which has the Active Directory on, which contains the usernames and passwords for users of the network. It also has a certificate authority, which will issue individual certificates to the wireless devices when they want to connect to the network. Second server is the Ubuntu server. It has the DHCP on it, which will allocate dynamic IP addresses for the wireless devices, and it also has the Apache package on it, which enables to create a default web page that the wireless devices might end up having to.
Would this be easy? So would the guy be able to go down to PC World, pick up his bits and pieces, come home, plug it in, and it works?
Might be a bit overkill for your average person on the street. If you want to do basic accounts, you can do, but this network, probably small computer business might be good for. Average home user, sack it off, no point.
Okay, cool. All right, so that's that bit. Now, what about down here? I've got an iPad, an iPhone, and my laptop, and I'm guessing this is the access point, is it?
Yeah, that's correct. When the wireless devices want to connect to the network, they'll attempt to connect to the SSID that is being broadcast by the access point. Once they do try to connect it, they'll have to enter their usernames and passwords, which will be sent from the access point through the switches to the Windows server. Once the usernames and password are allowed or denied, the server will send a certificate back through the network to the wireless devices. They might have the option to accept or deny the certificate. If they do accept it, then it'll get sent back through the network with the usernames and passwords with maybe a hash value and allowed onto the network. Once that bit has been authenticated, you obviously want an IP address, so the wireless devices will send out DHCP Discover packet to any DHCP service on the network. Get the layer 3 switch does have an address, forwarding address for the DHCP server, so I'll get sent to Ubuntu server here, which will reply to the wireless devices. They'll negotiate terms such as how long the IP address will be valid for, the default gateway, DNS server. They'll get an IP address, and then they'll be allowed on the network.
I'm sat in my lobby, right, with my iPad, and I've connected to the guest network on your network. Can I then get to any web page?
The access point has been set up so that all HTTP traffic is allowed to get anywhere. They can also do name queries and such from the wireless network to anywhere as well. But whether that's allowed, whether the request will be fulfilled is a different matter, depending on what the software and the route has been configured.
So, for example, if you've got your iPhone and I've got my iPad and we're both connected to here, can I actually find out your IP address?
No, because if you do manage to discover the network address and try and ping it, just get dropped by the access point. The way we've configured it is you're allowed HTTP traffic, DNS traffic, pretty much anything else that you want to get through gets dropped.
That's the layer 3 switch you were talking about before, right?
That is correct, yes.
Okay, cool. How does that work? What's all that about?
Well, basically, traditional switches, all the connected ports, they all have to be on the same network, so these two interfaces might have to be on the same 192.168.1 network. But we've configured the layer 3 switch with VLANs, which means that it can connect to the same physical switch but different logical network. This obviously gives you a great security benefit. You can select which networks have access to which files, get certain speed bandwidth limits and other stuff like that. Much safer, and obviously get sent to the layer 3 switch so that can handle the traffic address. And it's also got layer 3 routing on, so traditionally the switch will have to forward the different VLANs to a router, which will have to obviously send it all the way back, pretty much wasting network resources. The layer 3 switch can basically sort the routes out itself and enable connections between the two different subnets of VLANs.
What are the green one? What's the difference between a static route and a default route then?
The default route is basically the device has gone through each of its individual addresses, doesn't know where to send it, sends it to its last resort basically. Static routes, you can have various, might have, you got your two networks here, 192.168 and your 172. That router can't see these hidden networks here. Basically, the static route will say, if it's got matches 192.168, send it back in towards the network. So you can see here 192.168, 192.168. If the web server wants to ping the router, instead of sending it towards the internet, it'll obviously match it up, send it back in. Without the static route, the server pings to the router, it will get through the switch, get to the router won't know where it's coming from basically, so just send it towards the internet, obviously get lost in the internet.
In our network, how does this change from that to that?
Basically, the route has been configured with what's called NAT. It converts maybe private to public addresses and back to each other.
Now, I don't type in 172.160.1 when I type in on my pad. I type in www.hellokitty.com.
Yes.
How does that get translated from hellokitty.com to 192.1600.0.1?
Yeah, well, it'll get sent to the router. Router will have a web address of a DNS, which will convert the URL into an IP address.
So we've got that sort of translating bit of software in our router already, have we?
Yeah.
I'm at home, right? Can't be bothered to come into lectures, but I need access to my work that's on my university network. How do I? Have we got the capability for me to take my files off there and bring them home?
Yeah. Well, you can connect through the internet, but using that alone is very safe. Data can get stolen, get changed. But you can set the router up with a virtual private network or a VPN, which will allow your home device to connect to the router, authenticate itself with username, password, maybe a shared secret or a certificate. Once that's authenticated, you got your similar capabilities to take files off your server, access web pages and whatnot. So it's much safer because all your data is sent through a tunnel, which only the router and the home device can see, and all the data is encrypted.
And that was Duncan and Sam.